And I let everyone in middle.
All right, do you think we're okay to start going, Cece?
Yep, I'd just like to remind everyone to keep their mics muted during the speaker portion. And these talks are recorded, so they are uploaded onto our YouTube page. If anyone wants to see them later also, or send them to anyone that they know. So if you do not want to appear on camera, please turn off your camera. No information comes out from the names listed. So the only way someone would see you is via camera. And that's all.
Great, thank you. Welcome everybody. With my sort of ad hoc gavel here, I'll call the 1217th meeting of the Entomological Society of Washington to order. I have a little introduction here as both as the first meeting of the year, and also in light of what's been happening in the Capitol in the past day. I'll just address it briefly. So welcome everybody. Welcome to the 1217th meeting of the Entomological Society of Washington on January 7th, 2021. This meeting comes in the wake of unprecedented upheaval in Washington, D.C. and the breaching of the Capitol building. The Capitol building is situated just down the National Mall from the National Museum of Natural History, where under normal circumstances, our monthly member meetings are held. Due to security precautions taken by the city, including road closures and also due to work restrictions related to the pandemic, few, if any, entomology staff were working at the museum on Wednesday, January 6th, yesterday, when the events happened. As far as I'm aware, all members of our entomological community are safe and there was no damage to the museum. We all hope that remains so, and that peace and stability are returned to our nation's capital. That already appears to be the case. These events are very concerning, to say the least, but recently, because of COVID meeting restrictions, our monthly member meetings are now online, and we can and will continue to meet. And so I'm very happy to see you all here tonight, and welcome. This is also the first meeting after the Entomological Society of Washington elections that occurred in our December annual meeting. I'd like to welcome the following newly elected officers of the Entomological Society of Washington: Lourdes Chamorro, who is president-elect; Alan Norbaum is program chair; and Elizabeth Young is membership and communication secretary. Welcome, and thank you for your service. Mark Metz concludes his 3-year run as president-elect, president, and past president. He'll continue as editor. Cheryle O'Donnell proceeds from president to past president. I proceed from president-elect to president. And returning officers are Nick Silverson as curator, Gary Hevel as recording secretary, Abigail Kula as treasurer, and Mark Metz as editor. This past year has been unprecedented in many ways. The COVID-19 restrictions ended our in-person meetings in early 2020, causing us to cancel member meetings scheduled for April and May of last year, and also our annual banquet scheduled for June of that year, before our normal scheduled summer break. For the first time in our history, we turned to an online format for our monthly meetings, which began in October. And we look forward to a time when we can again gather in person, but the online format has clearly had a benefit in being able to, and allowing members of our society who live elsewhere or who otherwise could not attend meetings to attend. So in this sense, this has become a welcome change, and we hope to continue to be able to provide an online option for meeting attendance even after in-person meetings resume, hopefully soon this year. One reminder, if you've not already done so, I will encourage you to please renew your membership, or if you're not a member and joining as a guest, and please consider joining as a member. Abby Kula, our treasurer, sent out a reminder for, two emails last month as reminders to renew your membership, and included a link to a new Google form, which makes it easy for us to process new memberships and renewing memberships. So if you can, please use that. It's pretty quick and painless. You can also access the sort of older modes of renewal and signing up of membership through the website. But again, so please renew or become a member if you are interested. And finally, if you're having any issues with anything to do with society proceedings, including your membership or dues or receipt of issues of the proceedings, please let me know or one of the officers. So our email addresses are listed on the website, and you can find us there. And now we'll move to reading and approval of the minutes. So I'll turn it over to Gary Hebel for that.
The 1216th regular meeting of the Entomological Society of Washington was convened at 7 p.m. on the 3rd of December 2020 and was virtual by use of Zoom due to the coronavirus pandemic. There were 38 virtual members and guests. President Cheryle O'Donnell began the meeting by asking Recording Secretary Gary Hebel to read the minutes of the previous meeting. After the reading, the minutes were approved by those in attendance. Membership and Communications Officer Christina Say noted that there were 2 new members, those being Walter Fallis and Elizabeth Young. President O'Donnell offered the annual State of the Society summary for the past year, noting that the Society underwent unexpected problems earlier in the year due to the pandemic. Society meetings were canceled for April and May, and the annual banquet in June was not possible. During the summer, the Executive Committee held virtual meetings and hired a web designer. A decision was made to hold virtual meetings of the Society starting in October. Program Chair Cecilia Escobar gained 3 speakers for January through March, then 3 virtual presenters toward the end of the year. CC gracefully adapted the Society meetings to Zoom presentations. President-elect Jamie Zenizer successfully organized Society committees for auditing and nomination of officers. The nominating committee consisted of Alan Norbaum, Stuart McCamey, and Paul Goldstein. The auditing committee was composed of Young Kim, Torsten Vico, and Ben Krushek. David Adamski continued the Young Entomologist group, meeting in February, but then forced to cancel activities for the remainder of 2020. Editor Mark Metz managed development of 4 issues for volume 122 of the Proceedings of the ESW, which included 1,037 pages. There were 64 articles, 2 book reviews, and 1 obituary. Nick Silverson served as custodian, advising requesters that mailings were halted until the end of the pandemic and keeping records on requests and deliveries throughout 2020. Treasurer Abby Kula contended with society finances and formed a treasurer's report that was found to perfectly record the financial transactions of the society. Recording Secretary Gary Hevel displayed resilience in adapting to new technology of Zoom meetings. Membership and Communications Officer Christina Say recorded new members to the society, announcing such members at each meeting. An important portion of the annual meeting in December is the election of officers to serve the upcoming year. President-elect Jamie Zonizer presented the names of proposed officers, those being Lourdes Chamorro for President-elect, Abby Kula for Treasurer, Elizabeth Young for Membership and Communications, Nick Silverson for Curator, Gary Hevel for Recording Secretary, Alan Norbaum as Program Chair, and Mark Metz as Editor. These candidates were accepted by vote and will lead the society during 2021. No one offered any old business, new business, nor presentation of notes, exhibits, or specimens. Program Chair Cecilia Escobar introduced the guest speaker for the evening, Dr. Cesar R. Nufio from the Howard Hughes Medical Institute, who presented the topic, Grasshoppers of the Southern Rocky Mountains, Understanding the Impact of Climate Change on Communities, Species, and Populations over the last 50 years. Dr. Nufio divided the presentation into 3 parts. Why are grasshoppers important in grasslands? Using the Gordon Alexander Grasshopper Survey collection, and comparisons between the Alexander survey and a recent survey. Grasshoppers are primary herbivores, consuming 6 to 12% forage annually in the western United States. They are practical in studies because they are easily collected, easy to identify, and common. There are 133 species of grasshoppers in Colorado, and many organisms depend on them for food. The Gordon Alexander collection is composed of 65,000 specimens that resulted from grasshopper surveys conducted from 1958 through 1960. Extensive weekly surveys were made along an elevational gradient in the Southern Rocky Mountains in Colorado. Recent comparative surveys were conducted in the same sites from the 1958 to 1960 efforts, sometimes exactly the same when looking at photographs for localities. 8 main sites were utilized for surveys on a weekly basis between May and September in foothills to subalpine gradients. Grasshoppers have 5 different stages, and these were recorded in addition to species determination. In comparisons of species distribution and development timing, emergence patterns can be predicted, providing information for agricultural efforts. Spraying of insecticides, for example, can be done with more reliability. Temperature data was utilized during the surveys. Because Alexander collected near weather stations, temperature records can be charted in conjunction with growth patterns of immature grasshoppers. The recent survey was conducted between 2006 and 2015. Climate change can be analyzed utilizing data of species development along with temperature changes. 2012 was the second hottest year in Colorado during the past 118 years. Female grasshoppers in high temperature years were larger and had longer lives. They lay more clutches in warmer years than in cooler years. Dr. Nufio presented a tremendous amount of data, and his presentation was well received by the audience. At the end of the evening, Cheryle O'Donnell virtually passed the society gavel to new president Jamie Zonizer, with the gavel morphing into a hammer during the transfer. The meeting was adjourned at approximately 8:40 p.m.
Okay, thank you, Gary. Do we have any additions or suggestions to the minutes as read? Do we have a motion to approve the minutes as read?
So moved.
I've heard a moved. Do we have a second?
Second.
See a second, and the minutes are approved. Okay, next section of the meeting is reports of officers and committees. Do any of our officers have anything to report? Okay, we'll move on to the next section, which will be introduction of new members and visitors. And so I'll turn it over to Elizabeth Young, our new membership secretary.
We have one new member. Their name is Tanner Matson, representing the University of Connecticut. And yeah, welcome.
Great, thanks Elizabeth, and welcome Tanner. Any unfinished business? New business? I do have some items here, so I'm going to share my screen for a little bit. Okay, first, we're trying to track down some people, some email addresses that we've been getting bounced back when we're sending out notices for the society. So take a look at these, and if you are the owner of any of these email addresses, or if you know who they might be, could you please contact Al Norbaum? Thank you. And moving on, some sad news. In very recently, 2 active members of our community passed away in December of 2020. And we'd like to briefly recognize them here. Dr. Harold Robinson was primarily a botanist who worked on mosses and on the plant family Asteraceae, and served as a curator in the botany department of the National Museum of Natural History for most of his career. He also held a side interest in dog-capoted flies, on which he was a specialist and published extensively on. And he was an active member of the Entomological Society of Washington when he passed away in December of 2020. And Dr. Dennis Kopp. Dennis was a native of Iowa and earned his master's and Ph.D. degrees in entomology at the University of Missouri at Columbia, where he focused on the taxonomy and systematics of tree hoppers and family Membracidae. He went on to become a professor and extension entomologist at North Dakota State University for 13 years. In 1990, he accepted a position with the USDA Cooperative Extension Service in Washington, D.C. And in 1996, he became plant section leader for the Cooperative States Research, Education, and Extension Services, which in 2008 became NIFA, or the National Institute of Food and Agriculture. Dennis was an active member in many sectors of the entomological community and was known and loved by many. He became a fellow of the Entomological Society of America in 2010. And in retirement, Dennis volunteered 2 days a week working in the Heteroptera collection at the National Museum of Natural History, and was a regular attendee of our in-person meetings of the Entomological Society of Washington. On a personal note, I'm really going to miss Dennis a lot. I became very good friends with him over the past few years that I've been working at the at the museum. He was really a great guy, and I'm going to miss him dearly. Dennis passed away in December of 2020. We send condolences to the family and friends of Dr. Harold Robinson and Dr. Dennis Kopp. They will be missed. Okay, the next section of the meeting is presentation of notes and exhibition of specimens. This is, if you're unfamiliar, this is a section of the meeting where anybody can bring in an item of interest. It might be a new book or a publication or a specimen or a photograph. Does anybody have anything to present to us tonight?
Hi, Jamie. Yes, I do. I'm
Okay.
giving notice tomorrow. I'm actually president-elect for those who don't know me. And I have something to share with members who are present today. And even though this is a little bit, it's been out for a while, but we got this bug bingo a few years ago. Oh, I should get rid of my background. Hold on. I don't know if you could see it.
This is magic.
Yeah, let me see here. Okay, that's better. So it's a bug bingo, and Andy Polacek from the Museum of Natural History in London gifted this to us. And as you can see, it's still in its wrapper. I haven't wanted to open it. It's just really special. But it represents 64 species of insects, including Megaphragma. So Megaphragma is this tiny little wasp, and Matt Buffington can tell you a little bit more about it. But it even has caddisflies, and it's probably a really awesome way to get kids really interested in insects playing a game like bingo. So I just wanted to share that, and I'm not entirely sure how you can get bug bingo, but I'm sure if you Google it, you'll be able to get it.
Awesome, thanks, Lourdes.
I've got something, Jamie, but can you let me share my screen? Is that possible?
I think it is. If you go to the, hold your cursor. Yeah.
Okay, so here's what I'm working on now. This is what I did today. Can you guys see that?
Yeah.
So this is if you guys have been following my posts on Facebook and stuff, this is Vespa mandarinea, the Asian giant hornet. And this specimen came from the nest in Washington that they radio located. And this particular specimen is actually, I just mounted today, the actual radio locator used to find what they call nest zero. So that's what that line is shooting to the left. And it's nestled around the petiole there between the mesosoma and metasoma. That was not a trivial curatorial project, and something I'm not actually used to, since this is about 2,000 times larger than what I'm normally handling. But Floyd Shockley and I are working on putting this together for the museum and hopefully making a display in the insect zoo. There's a little window there that the entomology department actually has complete control over, and we can post whatever we want in there. And I think it's time for a new display. And this would be a really neat kind of merging of technology, natural history, and invasive species cooperation and research. So anyway, that's what I've been doing today.
How did do you know how they got that radio located on the live wasp?
Yeah, so that's a good question. They subdued the wasp with CO2 to slow it down, and then they glued a little strap of, basically it's kind of like twine or horsehair. They glued that around the transmitter. And then I kid you not, they tied the little strands around the base of the metasoma. Because I asked the guy who did it, I'm like, look, I'm trying to recreate the specimen. How'd you guys attach it? It looks like you tied it. And he tells me, yeah, we tied it. That's like gutsy, man, even with CO2. I don't think I'd do that.
That's awesome, Matt. Thanks. So is that transponder? It looks to me like it's sticking out a good bit, like 3 or 4 inches sticking out from the insect.
It's about 5 inches.
Wow.
And it's as thin as a micron, micron pin. Like it's about a hair diameter. So you can brush it quite nicely, and it's very flexible. So, and it's incredibly light. The whole thing weighs almost nothing. So it looks like it's kind of a hassle for this hornet here, but I bet it wasn't at all. It was a fraction of the weight that they're normally carrying around with them. It wasn't in their way of flying.
And I'd like to add that this has been top secret for a while.
Yes, that's right. Thank you, Laura. This has been top secret for a while because we didn't know. Let's just say there were a lot of negotiations to get this little radio transmitter, and it was really we didn't want to make an announcement and then like not get it. So we waited, and but this is the right community to appreciate something like this.
Very cool. Thank you for sharing.
Yep.
Did this particular hornet murder anybody?
I'm not aware of this particular hornet committing any crimes whatsoever.
Jamie, I just had a book to share. I don't know how well it would work on this format. I hold it
Okay.
up.
Sure.
Oh, it's backwards, isn't it?
I know. Well, I can see it forwards.
It looks
Anyway,
fun.
last year there was a special issue of the Israel Entomological Society published in honor of Amnon Friedberg, who's a really renowned dipterist. Any of the dipterists in attendance will certainly know his name. It's got a lot of great articles, but it was a really nice honor for him. And fortunately, he passed away later in the year, so it was sort of just in time, I think. So sorry, I can't pass it around to let everybody see.
Thank you for that.
Yeah, thanks, Al. Anything else to share?
I have a little screen share.
Okay.
See if I can do it. I'm not seeing it yet. There it is. Just want to wish everybody a happy Buggy 2021. And I have a little picture. I don't know if it's going to go down. I'm trying to get it to move. This is a leaf of a violet I turned over a few years ago, 2017. This is in my garden, and this was on it. And I suspected some sort of a lacewing, green lacewing, larval mass, a trash mass, or whatever you want to call it. And I was wondering, I don't know if Warren Steiner is here. I thought maybe he would know the species of the chrysopid, or maybe somebody else does. Maybe not. Maybe that's too hard. But anyway, I haven't seen that many of these trash piles that the larvae carry, but this is the most symmetrical one I've ever seen. And I assume that the little hole in the middle is where the adult came out, unless some parasite came out instead. I still have the specimen, but I haven't dissected it or anything like that. That's it, folks. Thanks.
Okay, thank you, Ed. I
How do I,
to stop sharing your screen so we can.
let's see if I can figure out how to do that.
It should be near the top of your screen. A little red box that says stop sharing.
Yeah, too obvious. Thank you.
Okay. Thank you. Okay, anything else to share? Okay, we'll move on to the next sort of main section of our meeting, and I'll turn it over to Program Chair Al Norbaum to introduce our speaker for this evening.
Okay, thanks, Jamie. First of all, before I introduce Cheryle, I'd just like to thank Cecilia for, first of all, serving as program chair for several years, and also for running the Zoom part of this meeting, because we'd be lost if you were totally relying on me at this point. I also had a brief anecdote about Harold Robinson. When I was an undergraduate in Philadelphia, I think it was 1979, I went and volunteered at the Academy of Natural Sciences. And the curator there said, okay, I'm going to give you this project to curate the Dolichopodid collection. And he gave me a copy of Harold's revision of the Eastern North American Dolichopodids. And that was my first introduction to flies, and I ended up being a fly taxonomist. So it's kind of a small world serendipity kind of a thing. Harold was responsible for that too. But anyway, now I would like to introduce our speaker, Cheryle, who probably doesn't need much introduction to most of this group, as she was our most recent president. But I'll read what we have here. It's Cheryle O'Donnell is the National Taxonomic Specialist for Thysanoptera and Psiloidea for the USDA APHIS National Identification Services. And she's the curator for the NM&H, Thysanoptera, and Psiloidea collections. Cheryle worked in the electronic and cryogenic manufacturing industries for 16 years, but returned to academic studies in 1994. She received her AS in biology in 1994, BS in agriculture systems and the environment in 1997, and MS in plant protection and pest management in 2000, and a PhD in entomology, systematics, and taxonomy in 2007. The latter 3 degrees at the University of California, Davis. Cheryle started her career with USDA in 2008 as a port identifier in Nogales, Arizona, and served as an AI at the ports of Miami and Fort Lauderdale, Otay Mesa, California, and while on a TDY at Blaine, Washington. She's one of the core members of the PPQ Molecular Diagnostics Working Group and has been a national taxonomic specialist since 2015. Thank you for doing this presentation, Cheryle.
I appreciate the introduction there. I'm going to go ahead and share my screen. Let's see here. We will get this started. Let's see. There we go. All right. So we just finished Christmas, but I hope you all look through your live Christmas trees for thrips. I'm sure that was a daunting task if you did. They're pretty small. I'm going to talk to you a little bit about Christmas trees and thrips of recent information I have for you. So thrips are the order Thysanoptera. Thrips is the common name. The Latin meaning for Thysanoptera is fringed wing. And you can see the cilia on the picture down at the bottom left-hand corner. All of those hairs along the wing margin are why this is called the fringed wing. And one of the misnomers for most people who talk about thrips, even one thrips is a thrips, always with an S. So Thysanoptera are very diverse. They can be, as these pictures indicate, very different colors. Some are winged, some are not. Some are
Cheryle?
Yes.
It's not advancing, your presentation?
It's not advancing?
Right. And maybe if you share your entire screen. at presentation mode. It doesn't seem like it's
I
advancing.
think it's because I'm using 2 different computers. So let me see if this makes a difference here. Nope, that didn't do it. Nope. I think what it did is it transferred the slides to my.
That looks better, yes. But
So
you have like two like a split screen now.
I do?
Mm-hmm.
That's interesting because we were doing just fine earlier, but let me see here. Let's go to presentation. Let me start over here. Let me go this way. Display settings. There we go. Is that better?
Yes.
All right. It switched over when I did my trial run earlier. All right, so I talked about the Thysanoptera and the Latin meaning. Now we're going to go to the Thysanoptera diversity. Again, there's sexual dimorphism. We even have parasitic thrips that attack Hemiptera. We also have semi-social groups that herd their young out during the day and back into a quiet place so they're not predated on. There's just a lot of diversity among the Thysanoptera, and they are found on all the continents. The group is classified as closely related to the Hemiptera, and that is morphologically and molecular support. It's interesting that they are in the Paraneoptera with the chewing and biting mandibles, as you see with the free-living and parasitic lice. It's interesting. But if you think in terms of how they evolved into piercing, sucking mouthparts, it makes perfect sense because both Thysanoptera and Hemiptera have that. There are 2 suborders in the Thysanoptera, and they are distinctly different, and we'll talk about the differences in the next slide. But you can see on the top right-hand corner, this is the Terebrancha, and the bottom left is the Tubulifera. And they have very distinct characteristics, and we'll talk about just a few of them here in this slide. You'll see the 3 columns, 2 columns on the right are the Tubulifera and the Terebrancha, and then some characters on the left that actually depict these 2 species quite well. I mean, these 2 suborders quite well. The wing veins are not present in Tubulifera, and they are present in Terebrancha. The articulated fringed wing cilia in that figure 8, if you will, remind me down the road. I will talk about that again, but we don't have that in the Tubulifera, and it's present in Terebrancha. We have wing holding setae for the Tubulifera. It's not present in the Terebrancha. And that is because there are no wing veins in the Tubulifera. And at the position of rest, the wings are set one on top of another. And each one of the wing holding setae actually come up from the abdomen and hold on to the wings on every single segment. So it's kind of Velcroed down, if you will, with these little hooks. The Terebrancha wings are set side by side, a little more structure in those wings, so they're ready for flight. Abdominal segment number 10 is a tube and Tubulifera, and it's much more conical in the Terebrancha. The ovipositor on the females shows as an irreversible chute-like structure on the Tubulifera. And if you can think in terms of a thrips walking along the substrate, the chute just allows an egg to come out and stop onto the plant material. Whereas Terebrancha actually has a saw-like ovipositor, and they walk along and then they back up and insert their ovipositor and drop an egg into the tissue. So totally different mechanisms there. In the 2 suborders, we have 8 families, 7 in the Terebrancha and 1 in the Phleothripidae. You can see that there are about 3,000 species. There's actually over 3,000 species in the Phaeothripids. And in the other groups, we have small species numbers until you get down to the Thripidae family and the two subfamilies within there. And we're going to really focus in on the Thrippinae because those are the plant pests. Those are the plant feeders for the majority. They're the ones that anytime you have thrips as a pest, they are generally in this group. The asterisk number 13 there, this is also the group that is well known for Tospovirus vectors. There are 13 species that actually do transmit Tospovirus. The life stages are pretty interesting as well. Doesn't really tick all the boxes of all of the metamorphosis, but it's an unusual character in that sense. So we have egg stage, the first instar larva, a second instar larva, and then you have a pro-pupa stage. And that stage actually still continues to feed and move around, but it's much more sluggish. It's really slowing down its metabolism, just kind of topping off the tank as it feeds. And then the pupa is really quiescent. And generally, once it's it has morphed into the pupal stage, it actually falls off the leaf and into the leaf litter below, where it molts into the adult, either a male or a female. And in this particular case, this is Franklinial occidentalis. There is a male and female, and generally speaking, the males are always smaller than the females and light in color. So this is just a depiction. It's an old picture, but it's a very interesting one. And you will need this in your trivia parties if we should ever get to go back to those again in the days. This is 4 families here. The Merothripidae is a fungal feeder, so the mouth parts are short and stocky in the mouth, in the head. Aeolothripids are predators and plant feeders up in the top right-hand corner. That's also short and stocky in the head, but it's a little more well-defined. The Phaeothripids on the bottom left are fungal spores feeders and plant feeders and gulf farming. And then we get to the Thripids, and those are the plant feeders. And if you can think in terms of maybe how this piercing sucking mouth parts actually evolved to the Hemiptera. The Hemiptera are really big feeders, and most of them are in xylem or phloem feeders or some kind of intercellular mechanism for feeding. This group feeds cellularly, so they don't need that big mandible set. And possibly that's the reason they are asymmetrical, which means you can take that to your trivia party again. This is an insect that is asymmetrical because they have an atrophied mandible. That's what those black marks where the big red arrow is. That's an atrophied mandible, and all thrips have them. So in the next few slides, I'm going to show you some scanning electron microscope pictures that I've taken a while ago, but they're just really good for showing some of the textures, the reticulation, and the CD that we look at for identification. The picture that you see here on the screen is the fronds, or basically you're looking right straight down at the head of the organism. The antennae are coming out towards you. The red round composite eyes are shown here on the left and the right. At the top, you'll see one ocelli and just barely see the profiles of the other 2 behind it. And that's the dorsal side. And then below it is the ventral side. And you can see the palps and the point where the mandibles come down, and the piercing sucking mouth parts are shown, not shown in the picture, but they're below that. So one of the structures—
We can't see that slide yet.
Sorry?
We can't see the lower view.
What lower view?
We're still looking straight at the head.
Yes, that's exactly.
Okay.
I was just orienting you to what you're looking at.
Okay.
Okay. So we have 3 ocelli at the top, and all that reticulation, those raised reticulate squares, or not really squares, they're irregular rectangles. Those are characters that we see in the Panketothripinae subfamily, which is a very unique structure in many of the organisms in that group. So one of the things that we use most frequently in the identification of thrips or descriptions of thrips are ketotaxy, the placement of setae, the description of setae, whether they're acute, as you see in these pictures. This is the head, the pronotum, and parts of the thorax. Whether those setae are acute, blunt, expanded, leaf-like, are all different kinds of structures that help us to identify thrips. The placement around the ocelli. So ketotaxy is extremely important in the way we describe and how we identify thrips species. Morphological structure is sensoria. We're looking at the sensoria here. This is the Johnson's organ on the second antennal segment, plus that sensoria, which is the big, large setae, if you will. It has those lines of structure on it that are probably chemosensors, but those characters can be either straight and simple like this one, or it can be forked. They can have beads around the antennal segments. There's just a lot of different combinations that separate the groups within the Thripidae. Here we have a spiracle. This is that long, you can see it in the bottom right picture, a little more defined. It's up in the thorax. Can you see my cursor right in here? This is the large version of it. So you have these pores, and on top of the pores, you have facets. And those facets are counted on spiracles in a lot of our different species, because some of them are multifaceted. So very, very, I mean, if you look at it at thrips, I'll show you what they look like and how big they are a little bit later, but this is a good way of looking at the very, very detailed characters that we look at for identification. We're back to the figure 8. So this figure 8 kind of, to me, is fascinating. What we're looking at here is the wing of a thrips. And we're actually going to be looking at the structure right here at the posterior margin with those long cilia. So here's the SEM, and let me orient you to this. This is the anterior margin of the wing. Here is the first vein. Here's the middle section of the wing. Here's the second vein. And then here you have these cilia coming out of a figure 8. In this particular one, the arrangement of that cilia is between the upper and lower notch. This one is in the same position. This one is in the lower notch, and this one is in the upper notch. This is a very interesting and intriguing component to the Thripidae, because if you look at the sides, the pleurotergites on each one of the abdominal segments, they generally have this cone-like structure. And on the 8th abdominal segment, they have another cone-like structure. And most thrips, if you see them in nature, will actually bend this way up like a scorpion, and they'll rake their leaves, their hairs along the wing to either put that cilia in the upper or lower socket, depending on whether they're feeding and staying on the plant material or taking flight. So whenever you look at thrips on a leaf and you see them start to do this, you know they're shifting gears, so to speak. It's a very interesting character to me. All right. So in the genus, we have 105 species of Scirtothrips. Genus Scirtothrips, we have 105 species described right now. 15 are known from the US that are described. We also have, they're also leaf feeding, young growing leaves. They're worldwide, and they're generally less than 2 millimeters long. And this is a picture of Scirtothrips dorsalis, which I'll talk about in a few minutes. So several undescribed species are found in North America, but unfortunately, we don't have a great deal of individuals to study. So some of them have been sent in for domestic finds, but generally speaking, we have a lack of follow-up collecting expeditions to gather more specimens, a lack of a series of individuals from which to describe a new species. This group has had some difficulty with its classification and characters. So in 2006, Rugman Jones et al. Did some molecular work to tease apart some of the species that had been named by other specialists in different continents that actually were synonymized. So there were quite a few synonymized in that study. So hopefully a little more clarity in the species in this group. Thrips that have been introduced to the United States, like dorsalis, that I showed you a picture of a few minutes ago, have always come to the forefront because they're pests, or they find their way at being a pest in the country. So the Thrips dorsalis was found in 1991 in Florida, causing a lot of feeding and egg laying damage to numerous hosts. And that picture up at the top right-hand corner shows not only the plant material completely deformed, and the peppers not well, they can't be used for anything more than soup or something else, but they can't be sold as fresh fruit. The Thrips per se was brought in, smuggled on an avocado plant into California, and it was released and detected in 1997, and eventually decimated the avocado industry to between $7 and $13 million. So in 2016, I was sent one individual of Thrips that had a preliminary identification of Thrips dorsalis, sent in from a Christmas tree farm in Pennsylvania. The specimen was identified to Thrips species. We couldn't match it to anything in the collection at that time, and we only had one, so I really had no more to go on for that specimen. Additional requests were submitted the following years. Unfortunately, only one or two of those individuals, and not a lot of specimens were found in the collection by the. So in subsequent year, in 2018, a request was sent in from the Pennsylvania Agricultural Department asking us to come and visit the commercial Abies farms because they were having significant damage to their Christmas trees, enough to point out that they would not be able to make a sale of any one of their trees that year for Christmas. So I went out to the farms to confirm that it was or was not Thrips dorsalis. The day that I went, it was torrential rain. We had close to a foot. I had to take 3 detours to get to the farms because of flooding, but I finally made it there. We were drenched, and I didn't have a great deal of thought that we would actually find any thrips at all, because when it rains, thrips generally find really good places to hide, or they're washed away. But on the other hand, in this particular case, I found thousands. Thousands of individuals were collected, including the larvae, and numerous eggs were also collected at the time. I collected a lot of plant tissue and took it back to the lab for analysis. So one of the things that I did while I was there was to take a note of all of the Christmas tree farms that we had, all the Christmas trees there. You can see that they had excessive cone production. So the trees were stressed, they were showing the stress, and they were producing as many cones as they possibly could to survive, procreate. So we also had needle and cone drop, which was evident on the ground and evident on bare stems. So overall health of the trees was declining. So you can see here that needles turned yellow, as the bottom picture shows, are stunted and drop from the branches. And then you have these bare branches, which you can see in the upper picture here, and the lower picture right here. And then the tip, apical tip is just dying off. These, when they get yellow and brown like this, they just defoliate, they drop off. The developing cones, as you can see here, they don't flush out nicely, and they wilt, turn brown, and die and fall off. So if you think about this little tiny growing tip that I showed you earlier in this area right here, and you think about Whoville and the Whoville that lives on the snowflakes, if you dive into this tip, this is what you get to see. And you can see all the thrips that are inside here. These are all larvae, and they are feeding on all the needles and just having a heyday. So they're having a party. It was pretty impressive. Then I started pulling apart the bracts of the cones, and you can see up here in this upper left-hand corner, this is the Thrips larvae. This is one bract, and it's meshed up against another bract. These guys were just stuffed in here. You can see on this bract, the center had died, and the only thing left of that cone was the outer edges. And this picture shows the egg deposits, one here, and one here. And this is just one bract of a cone, a developing cone on top of that. These are the growing tip, or the new needles that are being flushed out. These are yellow, healthy needles on the outer edge. They're very bright yellow. And then this brown area here is where all the thrips were feeding on the needles. Those will all fall off. So even at the very tip of a growing tip, they've already realized damage before they even flush out. This is the bundle sheath, if you will, for all of the needles that start to emerge, and this whole needle drop was evident. And you can see how big these are. They're not very big. This picture shows healthy needles and one damaged needle from feeding. And here you see a immature thrips feeding on the needle, one needle, a developing needle. So sorting through the collection after, basically what you do is you bring all the plant material and all of the alcohol specimens that you've collected, and you rinse them in ethanol, and then you pour them through a coffee filter, and then you start pulling out all the plant material. And this is the members that you have left over. So does anybody recognize these large fat individuals in the center of this picture? And Al or somebody, if you see the chat and see anybody in there saying anything, please let me know.
Are those ethochords?
No, those are adelgids. So good try though. Yeah, these are the immature adelgids. How about these round black and gray balls? Those are spider mites. But then you can see the number of thrips in here. So there's a lot of thrips in here. As I said, I probably have an estimate of about 5,000 thrips I collected that day. That's a pretty good infestation. So the identification process, is this Scirtothrips dorsalis? And if it's not, then what species is it? So again, we have to do all of our sleuthing. Examination of the specimens revealed no levels of determination, a species level of determination. These were not Scirtothrips. This is Scirtothrips here, and this is the new Scirtothrips that I'm trying to find out what it is. The literature searchers confirmed that the genus was appropriate, Scirtothrips, but the keys did not shed light on the species level at all. No known US species with Abies species as a host, and Scirtothrips were found on Abies. Were any Scirtothrips found on Abies and on other continents? That was my next question. So one of the things that we do when we find something new is we have the opportunity as curators to look through the collections. And I was able to look through all of the type specimens in our collection for the National Museum of Natural History, and found nothing that was named as a species compared as a host on Abies, or was even found on Abies, until I went to the unknown boxes. There are 3 boxes of unknown Scrotothrips collected in the United States within the National Collection. And you can see the red circle at the left. There are 7 slides in there, all females, that were collected in 2007 at the New York Botanical Gardens. And bingo, this is it. As you can see, when I'm talking about these thrips, this little tiny patch right here, that's the thrips that we're talking about right there. So those pictures I showed you on the SEMs were really, really nice to see, but you can't see that here. So we know that the genus was not known on Abies. So now through literature review, we know that the species have a wide host range, but does not include Abies, even for those that are polyphagous. The interception records showed only 1 domestic request, and that was the one from the Botanical Gardens in New York, and that was in 2007, and that was through 3 databases. And this particular find interception was from SEL. So my next job was to talk to all of my colleagues and to find out through other museums if we had other species that had ever been collected on Abies anywhere in the world. And through all of my colleagues and those who have traveled and who are curators at the museums do not have any records whatsoever of the Scrotothrips on Abies. So now my job is to describe the thousands that I have, name some type specimens, and be able to publish this. But the composition was very interesting. As I said earlier, these guys can be diverse, thrips can be diverse. And in this particular composition, the collections in Delaware, New York, and Pennsylvania only contain females and larvae. There are no males present, and both larvae and adult females are unique compared to other Scrotothrips. And again, specific host of Abies. That's really important. So you can see here on the left, I have the pictures of the Scrotothrips adult and immature, and I have some little snippets of the 2 keys that I've developed that describe this species in comparison to the ones that we know, both adults and larvae. And preparation of publication, that's what we're going to hope for this year. That's my 20 and 21 goal. So it's getting there. And whenever you visit a Christmas tree farm, you must go see the Christmas deer, Santa's deer, and this is Prancer. He was at the farm that day. So I want to say thank you, and I want to take any questions that you may have at this time, and let me know.
I have a question, Cheryl.
Yes, Stu.
So would you have is there a special name for their kind of metamorphosis? Because it's not really holometabolous.
Holometabolous.
Oh, but it's exoterygote. The wings are external in the pupil.
Yeah, they are external, but yeah, because they have a full pupal stage.
Okay.
Anybody else?
Carl, this is Alan.
Uh-huh.
I remember back when Dave Nickel was working on thrips for a little while, he was so excited about using SEM to look at thrips. Like how much has SEM like changed thrips taxonomy? I assume it had a pretty big impact. And just a follow-up question, like I remember Ron Ochoa talking one time about slide-mounted mites. They thought they had certain characters, and it turned out like when he started looking at them with SEM, it turned out a lot of those were just artifacts of the way they were, mounted on the slides. Like, do you run into that problem with thrips as well?
It's exactly true. Thrips, because we flatten them out on a slide, it's hard to see that three-dimensional component like I showed you in the SEMs. And there are some structures that we really need to see from the side view or from the front view. And I know for myself, it's been very enlightening to look at larvae, especially in cryptic species like all the Frankliniella. There's some characters that we just cannot see, and I'm hoping that we can flush some of that out with SEM. But yeah, it's definitely a challenge. I wish I had more time to work on the SEMs, but you know, I got this much in my brain to do and only this much time. So, you know, it's a tough one. Good questions though.
I have a question, George.
Yeah.
Did the growers, the Christmas tree growers, did they say they've been seeing this for years, or was this new to them?
That was the thing. They had been seeing it for a while, and the day that I went up to do collecting that year was the biggest population of thrips that they had seen. They were just inundated with them, and they said that it hadn't been that bad that the year before, and they just sprayed. But they weren't sure that they were using the right chemical because they didn't know what the species was. So when we found out what it is and found out that it's a North American species, it's not something that's been introduced, then they could, you know, treat it appropriately, so to speak.
So they lived with it until it just got bad enough.
Yeah, well, that's typical. I mean, thrips are darn tiny anyway. Generally speaking, they aren't gonna go after it really big until it's really starting to show significant damage where they can't sell it. In this particular case, he couldn't sell one tree that year. So pretty sad.
Cheryle, I have a question. This
Sure.
is Sean Gilhouse. You collected thousands, you said. No males. Is it likely this is a parthenogenetic species?
Yes, this is not uncommon in thrips. We have wingless female groups that only you know, give rise to clones. We have groups that are species that actually have males, but they only come around during certain times. So when the population's a certain way and it's a chemosensory enlightenment, if you will. Even the cones in the cycad cones in Australia, there's been a lot of work by Irene Terry, that, you know, the males don't actually come around until the cones heat up, and then the females entrap them so that they can mate. But it's just a really bizarre, this group is just really bizarre. There's no two ways about it. But yeah, we have a lot of groups that don't ever have any males, never been a collected male anywhere. And this doesn't seem like we're going to have one.
And so, and also you mentioned you're considering it a North American species, but could it, I mean, I guess because it's only been found so far in North America, but you have one record in a botanical garden in an urban area, and then from the Pennsylvania, Delaware area. But could also be something that was introduced from somewhere else and just not known from that site yet? I don't know how well sampled thrips are on Abies.
No, it's perfectly fine. I totally understand. That was my first thought, is that this was introduced, especially because it came from the botanical garden. That was the original find. Unfortunately, that botanical garden was well established over 15 years. So it wasn't a new introduction with that botanical garden. So I started talking with all of my colleagues immediately, finding out if they had anything or knew of any prolificous species that would actually go to Abies, and nobody had anything.
Okay.
And then sharing pictures with my colleagues to show them, you know, the differences between the larvae and the adults was also a really big enlightening discussion, and nobody had seen it. So that made me feel even better. The only other thing that I can think of is I wasn't able to get in touch with anybody in Canada, but that would be my next outreach.
Thank you.
Yeah, it's a good question. Thank you.
I got a question out of left field. What are you holding in this picture? It looks like a fishing rod.
Oh, no, it's just it's a very good question, but the phone, I have a phone in each hand. One is the government phone, one's my personal phone. And that is a guide rod between the for the fence so that it doesn't collapse.
Oh,
No guide.
Oh,
Yeah, I'm feeding them carrots.
okay.
So Cheryl, there's a couple of questions or comments in the chat.
Go ahead.
One person asked if you could close your screen so that we could see you talking again.
Oh, sure. I was more concerned that I might need to go back in the slides, but that's okay. Great.
Yeah, I don't know. Julieta Brambilla, I don't quite understand your question, Julieta. It says 2005 Florida Thrips dorsalis. Julieta, are you there? Maybe you can re-ask that question. Is she there?
Oh,
Maybe she's left.
but it looks to me like
Hello,
she's,
this is Jamie. This is Felipe Soto.
Yeah. Hey, Felipe.
Hello, Cheryl. How are you?
I'm good. Thank you.
It's just that I mean, I don't have the records, but Julieta worked on the Thrips dorsalis when it arrived in Florida, and she seems to remember that it was in 2005 or something like that. And what she posted was the link to the pest alert, I think.
Yeah, actually, I have records from DPI of 1991. So I went with that one. And it may have been that it was just found at that time and really wasn't a big problem until 2000.
Yes, it may be that it finally got established and started to cause damage around 2005. Yeah.
Yeah.
So
And now it's a problem throughout the states. It's in California and Mexico now.
So every year we get all these Christmas trees here in Florida, and I've never looked for thrips. It's usually for scales, but next year I'm going to start looking because yeah, I mean, there may be some treasure in there. Yeah.
Yes, exactly.
I have a general question. I'm just wondering if you could speculate on the thrips biodiversity in the Washington, D.C. area. I know there's a couple species that really zap plants in my garden, but I'm wondering, how many species you think are around here and so forth.
You ask a good question, and I really don't have a good feel for what's in this area.
Okay.
I mean, I have a feel for there's a lot in this area. Number of species, I couldn't even guesstimate. I really couldn't. There's a lot, and they're all different. So the Terebrancha is probably the group that's most hitting any of your gardens. Phlaeothripids, again, are the fungal feeders. Some of them are plant feeders, but they generally don't rise to a big problem. So yeah, it'd be interesting if you could collect them. It's always fun to get people to collect for me and bring them in. That's also good.
Yeah, I think I have the
Can everybody hear me?
Oh, yep.
Yes.
Anyway, a good way to collect thrips is yellow bowl traps or some kind of colored bowl traps. But of course, you don't get the plant host and you don't get the flightless species. But it's a great way to get a lot of thrips. And it's worked for me on trips. So try that.
Yeah.
It'll tell you what's in your area.
Yeah, that's definitely true. That's a good suggestion for Ed too. That's good.
Yep.
So
Cheryl, Diana asked, can you do DNA analysis on thrips? I think you said early on there's molecular phylogenies, but is DNA being used for diagnostics at all? Or?
Yeah, that paper that I talked about with Rugman Jones, that was a molecular paper on the pest species of Skirtothrips, which is pretty much all of them that we know of. So a lot of the specimens that are species that were described in Mexico were synonymized with some that were already in North America. I'm hoping to add the DNA analysis from this one. It's been submitted to our molecular lab in APHIS, and hopefully we can add that to that analysis and have some barcoding for that that species as well. So we'll add it. That's my goal.
So Matt Buffington commented, thrips on trips. So thank you for that comment, Matt. John Gelhaus asked, do you have any special tips for slide mounting?
I learned from Lawrence Mound, and I actually teach that to anybody who asks. So I mount my thrips on the slide cover, and then use the media that I put down and the heavier slide as I put it down to actually move the wings out. I don't manipulate the thrips at all. So other than, clearing and putting in balsam or on Hoyers, depending on what I'm doing. But that's how I mount them. And so to me, it's quick, down and dirty, and I let the medium do the work of spreading the wings, not having to sit there and fiddle with them and try to get them in the right plane. This way, it's just real nice and easy. But I learned that from Lawrence Mound back in 1997. So.
So if you do it upside down, so if any of the medium comes out the side, like if you have a little bit too much, do they get stuck then to the surface? Or
quick flip of the wrist. So you put it down, you watch the medium touch the glass, and then you pick it back up, and it's done. It's that back.
You don't leave it that way.
Nope.
Interesting.
Yeah, it's real nice.
I don't know if you know about the collection in University of Minnesota. That's where I went to university, and in a person with an Indian name, Anata Krishnan, collection is there, and
I actually worked with her. Yeah.
Oh, okay.
Yeah, I was doing some work for her. She was having some problems with thrips, and asked that I try to help her and her student identify some thrips. That was just a couple years ago. So yeah, very nice. Good. I see we have a couple other questions here. Bill Murphy to everyone. Oh, can we see the, I don't want to see that. Okay.
Yeah, I think that was all. Anybody else have any other questions?
I think there was one more for Julieta. What is the management for this high pest level in Abby's Christmas trees?
Because this species isn't on any labeled pesticide, they have to do a generic for thrips. And I don't know what that strategy is for the growers. And I sort of leave that to the agricultural department in Pennsylvania. That's kind of what their job is. And, I let them handle that. And they seem to have it under control, which is really, really nice.
I have a question.
Sure.
Yes. Did you say that you don't get a lot of male thrips, mostly female?
In some species, we have males and females. In this species, we have absolutely no males at this point. And there are several species in Thysanoptera that never have any males. They just clone their progeny, their daughters, so to speak.
I was wondering if the female, after she mates with the male, if she eats the male like the black widow.
No, this is not the case.
Okay.
All right.
Very good presentation.
Thank you. Thank you.
Yeah, it was great learning about thrips. I get them a lot in leaf litter samples.
Yes.
The way to collect them, and from very remote places. And I don't know if you wish to get them and incorporate them into the collection. I mean, I don't know how much time commitment that would be. And I had a question about your predecessors as curator. It looks like the collection is very well taken care of in a large collection, very important collection. So can you talk a little bit about that?
Sure. When I started in 2015, well, let me give you even more history. My mentors were Lawrence Mound in Australia and Steve Nakahara. And Steve retired in 1998, I think. And I was working on my master's at that time. And I had hoped that at one point they would hire a new Thysanopterus, but they didn't. They brought in Dave Nickel, who I'm also working with as an area identifier in the field. So I sort of have a long history with the predecessors. But when I came in, the collection was in the position that it's in the slide boxes, but it was on the old wooden bookshelves, and the lighting was terrible in the room. So I put in a request to purchase the compactors and was able to buy those compactors in 2008 and get them installed. Really lightened up the place. And now we have a nice place where we can actually grow. We weren't able to grow in the wooden bookshelves. So I'm really happy that we were able to do that. In addition, we've added a desktop SEM for APHIS, and we use that a lot for looking at specimens. What was, I was going to say something else. I can't remember now, but yeah, I'm looking forward to, growing the collection as much as possible in the next few years. We're working on it, but thank you. I appreciate that.
Hey, what's that thrips that bites people? I've been on my deck before getting bitten, and you look really close and it's the thrips. What are they?
They'll just test you. Any thrips will do that. Actually, what they're doing is they're just testing to see if that's a substrate they like. It's just a probe, and then they're gone. So
they're not taking blood meals.
Yeah, they don't do that. But there's a theory, because I'll tell you a little more trivia for that trivia party. The Tospo virus that they transmit, those 13 species transmit, what is a Bunyaviridae, which is an animal virus. And it's the only one that has moved and migrated into insects, and it's been done by thrips. So they believe that maybe in the evolutionary relationship between viruses and Thysanoptera, that the virus was in an animal that thrips actually did feed on, and it somehow evolved. And now it's a plant insect virus. So it's a very interesting theory. Don't know if they can prove it in any way, shape, or form, but it is kind of interesting. But those guys do hurt. When I was doing my research in Florida on ficus and thrips palmi, the farm next door would harvest all their green beans, and all the Franklinia bispinosa would come over, and they were just landing on me and biting, just piercing, sucking kind of, little. So I do know what you mean.
Yeah, thank you.
In greenhouses, Franklinia occidentalis is a pain, because they grow in very large numbers and they will bite and bite and bite. So yeah, there are several species that do that. Once they reach, the populations are large enough, they will bite you.
Yeah.
So Julieta made another comment, just said it's interesting that they are holometabolists while Hemiptera are hemimetabolists.
I know. It's pretty cool.
Yeah.
I kind of look at these as sort of a living fossil between groups somehow. I don't know. I mean, it's a very interesting group.
All right, well, if there's no more questions, I want to thank Cheryle for a really interesting talk. I know a whole lot more about thrips than I did earlier on.
Thank you.
I just want to tell everybody we have a really good speaker for next month as well. Stan Rubinoff, he's a lepidopterist at the University of Hawaii. I've heard he gives really good talks, so mark your calendars. I think we'll turn it back over to Jamie.
Yeah, great. Thank you so much, Cheryle. And thank you, everybody. That was a great discussion too. Very good questions. That was great. Thank you.
Thank you.
I wanted to point out that Cecilia put a link to our YouTube channel in the chat box there. So there's a recording of this presentation that will be posted once it's all processed. the previous meetings that were recorded are posted up there now. So that's another cool thing about this crazy new age that we're in. We can have access to our past meetings. So that's very nice. So thank you, CC. And thank you for your help again in doing the presentation here. Does anybody have anything else? Any other questions or any other comments before we close tonight? Okay, do we have a motion to adjourn?
Motion.
Motion to adjourn, second. I see a second from Matt Buffington. With that, we'll adjourn the meeting. Thank you, everybody.
Bye, everyone.
Thank you, everyone. Bye-bye.
Good night.
Good night.
Okay, bye. I will have the recording up hopefully tonight, if not by tomorrow.
Great. Thanks
Sounds
again.
good. Thanks, Cecilia.
Bye.
Bye.